In Level 2, we will use the definition of inverse functions and use the graph of a function to sketch the graph of an inverse of a function. A couple things about inverse functions. A function has to be one-to-one to have an inverse. So if it's one-to-one, it will have an inverse, which we call f inverse. Now, one thing about the notation, this is not an exponent. It doesn't mean f to the negative 1 power. It's not 1 over f. That's just a symbol we use for f inverse. So it's don't get confused. It's not an exponent. If a graph is not one-to-one, it doesn't have an inverse, or its inverse is not a function. So we're only going to talk about inverses when we have one-to-one functions. And then the graph of a function and its inverse are symmetric with respect to the line y equals x. That means if you reflect a graph over the line y equals x, you'll get the inverse. So remember, the line y equals x is a linear equation with a slope of 1 going through the origin. So if we reflect a graph over that line, we get its inverse. And then the next part, if a function f is a set of ordered pairs x, y, then the inverse of f is the set of ordered pairs y, x. So the x's and y's just switch places. And since the x's and y's switch places, the domain of a function is going to end up being the range of the inverse, and the range of a function is the domain of the inverse. So the whole domain and range switch places. Okay, so to apply this in example, looking at number 3, a function f contains 3 points. Determine 3 points on the graph of f inverse. All we have to do is switch the x and y's around. So for this first point, instead of negative 1, 4, we would have the point 4, negative 1. I literally just switched x and y. For the next point, switch x and y again, we would get negative 5, 2. And for the last point, switch x and y, we get negative 13, 7. So the explanation sounded a lot more complicated than it was. All we're doing is switching x and y, which means the domain and range switch places. In the next example, we are going to graph the inverse of a function. We're given a graph f of x, and we want to graph its inverse on the same coordinate grid. Notice that this function is one-to-one. A horizontal line would not touch it more than once, so it will have an inverse. And to find or graph its inverse, we're going to switch the x and y values of the points. So I'm going to make a table for the points on this graph. So this is a table of values for f of x. Okay, and I have the point negative 6, negative 3. My next point would be negative 3, negative 2. And then we have the point negative 1, 3. And positive 5, positive 4. So now to find points on f inverse of x, all we have to do is switch the x and y's of the points on the original function. So negative 6, negative 3 is going to become negative 3, negative 6. Instead of negative 3, negative 2, I do negative 2, negative 3. Next would be 3, negative 1, and 4, 5. And I plot those points. Negative 3, negative 6, negative 2, negative 3, 3, negative 1, and 4, 5. And I connect them. And you will notice that this function is a reflection over the y equals x line. Now for the domain and range, the domain of this function its lowest, we're looking at the original function, f of x, the one graphed in black. Its lowest x value is -6. Its highest x value is 5. And for the range, its lowest y value is -3. Its highest y value is 4. Now looking at the domain and range of f inverse, the function we graphed in blue, its lowest x value is -3. Its highest x value is 4. And for its range, the lowest y value is -6. The highest y value is 5. And notice that the exact domain and range just switched places. So the domain of the original function became the range of the new function. The domain of, or the range of the original function became the domain of the new, or the inverse function. So in every inverse function, the domain and range switch places from the original function. And now for our last example, we are going to graph a function we know how to graph based on transformations, and we're going to graph its inverse. So first we graph the function. If you remember from transformations, this function has a vertical stretch by a factor of 2, a vertical shift up 4, and it's reflecting horizontally over the y-axis. So I'm going to shift it up 4, and I'm going to be going to the left because it's reflecting over the y-axis. And instead of going left 1 up 1, I go left 1 up 2 because the y value needs to double. And my next point, instead of going left 4 up 2, I double the y and go left 4 up 4. And then my last point, I would be left 9 up 3, but I double that y part and I get left 9 up 6. And there is the graph. And now to graph the inverse, we are just going to take those points and switch the x and y around. So if I take my point over here, its ordered pair is -9, +10. So instead I go +10, -9. The next point, the ordered pairs would be -4, 8. I switch those and go to 8, -4. And my next point, -1, 6, I go over 6, down 1. Okay. And then the point 0, 4 flips to 4, 0. And there's our graph, G inverse of x.